Hi listeners, you are welcome to the continuation of our online physics tutorial class from your favorite student ScoreBooster, your online tutorial provider on UTME, JAMB, WAEC, NECO and NAPTIV exam. For today's presentation, we shall be discussing the concepts of ideal gas equation. I am Bangbade AA. Before we proceed, we need to consider the learning outcomes of this particular presentation, which goes thus. At the end of this presentation, listeners should be able to state the mathematical expression for ideal gas equation. They should also be able to interpret the parameters of ideal gas equation. And lastly, they should be able to solve relevant UTM questions relating to ideal gas equation. Now on to the concept of ideal gas equation. Ideal gas equation can be given as Pv equals nRT. I repeat, the mathematical expression for ideal gas equation can be given as Pv equals nRT. Now, P in this case represents the pressure of the gas. Phi represents the volume of the gas. N represents the number of mole of the gas. YR is equal to gas constant, whose value is 8.3 joule per mole per Kelvin. I repeat, P represents the pressure of the gas, Phi represents the volume of the gas, N represents the number of mole of the gas, YR is gas constant, whose value is 8.3 joule per mole per Kelvin. Now on to practice question. And the first question here for our practice comes from UTME 2009, number 20. And the question goes thus. The pressure of 2 moles of an ideal gas at a temperature of 27 degrees Celsius and volume 10 raised to power minus 2 meter cube is dash. Option A is given as 4.99 times 10 raised to power 5 Newton per meter square. Option B is given as 9.8 times 10 raised to power 3 Newton per meter square. Option C is given as 4.98 times 10 raised to power 3 Newton per meter square, while option D is given as 9.8 times 10 raised to power 5 Newton per meter square. Then we are given the gas constant R to be 8.3 times 10 raised to power 8.3 joule per mole per Kelvin. R equals 8.3 joule per mole per Kelvin. Now on to solution. The first step as usual is to write out the given parameters. And from the question, we are given the number of mole of gas, which is N, to be 2. Similarly, we are given the temperature T to be 27 degrees Celsius. And to convert it to Kelvin, we will add 273 Kelvin, making 300 Kelvin. Therefore, at 27 degrees Celsius will be equal to 300 Kelvin. Lastly, we are given the volume Phi to be 10 raised to power minus 2 meter cube. Now, we have to recall that the equation for ideal gas is Pv equals nRT. Pv equals nRT. And when we substitute for that, we are going to have our P, which is unknown, times V, which is 10 raised to power minus 2 meter cube, equals N, which is given to be 2, times R, that is the gas constant, which is 8.3 joule per mole per Kelvin, then times T, which is the temperature, which is 300 Kelvin. Then we can make P the subject of the formula by dividing through by 10 raised to power minus 2 meter cube to get P equals 2 times 8.3 joule per mole per Kelvin times 300 Kelvin divided by 10 raised to power minus 2. So if we evaluate 2 times 8.3 times 300 is going to give us 4987.8. Then times, when we take 10 raised to power minus 2 up, it will become plus 2. Therefore, we are going to have P equals 4987.8 times 10 raised to power 2. Then, when we take this to standard form by taking 3 steps forward, we are going to have 4.987 times 10 raised to power 5 Newton per meter square, making option A the correct answer for this particular question. Now the next question we shall be considering comes from 2010, number 22, and the question goes thus: the pressure of 1 mole of gas, 1 mole of an ideal gas of volume 10 raised to power minus 2 meter cube at a temperature of 27 degrees Celsius is dash. I repeat, the pressure of 1 mole of an ideal gas of volume 10 raised to power minus 2 meter cube at a temperature of 27 degrees Celsius is dash. So option A is 2.24 times 10 raised to power 4 Newton per meter square. Option B is 2.24 times 10 raised to power 5 Newton per meter square. Option C is 2.49 times 10 raised to power 5 Newton per meter square, while option D is 2.49 times 10 raised to power 4 Newton per meter square. Then we are also given the gas constant R to be equal to 8.3 joule per mole per Kelvin. As usual, the first step is to write out the given parameters. In this case, the number of mole N is equal to 1 mole of an ideal gas, so N equals 1. Then the volume phi is given to be 10 raised to power minus 2 meter square, while the temperature T is 27 degrees Celsius, which will be 27 plus 273 Kelvin, making 300 Kelvin. As usual, using the equation P equals nRT, then on substitute for the parameters, we are going to have P, which is unknown, times phi, which is 10 raised to power minus 2 meter cube, equals N, which is 1, times R, which is 8.3, then times T, which is 300 Kelvin. Then we can make P the subject by dividing through by 10 raised to power minus 2 to get P equals 1 times 8.3 joule per mole per Kelvin times 300 Kelvin over 10 raised to power minus 2 meter cube. So if we evaluate this using calculator, we are going to have P, pressure P equals 2.49 times 10 raised to power 5 Newton per meter square, making option C the correct answer for this particular question. Now the next question we shall be considering comes from 2015, UTME 2015, number 12, and the question goes thus: calculate the temperature of 6 mole of an ideal gas at a pressure of 7.6 times 10 raised to power 6 Newton per meter square with a volume of 10 raised to power minus 3 meter cube. I repeat, calculate the temperature of 6 mole of an ideal gas at a pressure of 7.6 times 10 raised to power 6 Newton per meter square with a volume of 10 raised to power minus 3 meter cube. Then we are given in brackets gas constant R equals 8.3 joule per mole per Kelvin. Now we're given option A to be 185 degrees Celsius, option B to be 201 degrees Celsius, option C to be 153 degrees Celsius, while option D is 126 degrees Celsius. As usual, the first step is to write out the given parameters, and in this case, the number of mole of gas N equals 6, the pressure P equals 7.6 times 10 raised to power 6 Newton per meter square, while the volume P is given to be 10 raised to power minus 3 meter cube. So, using the equation for ideal gas, which is PV equals nRT, on substituting for the parameters, our P, which is 7.6 times 10 raised to power 6 Newton per meter square, times V, which is 10 raised to power minus 3 meter cube, equals N, which is 6, times R, which is 8.3 joule per mole per Kelvin, times T, which is unknown. Then we can make T the subject by dividing through by 6 times 10 raised by dividing through by 6 times 8.3 to get T equals 7.6 times 10 raised to power 6 Newton per meter square times 10 raised to power minus 3 meter cube divided by, then in brackets put 6 times 8.3 joule per Kelvin per kilogram, and that will give us 152.6, which can be approximated to 153 degrees Celsius, making option C the correct answer for this particular question. Now on to practice question, and the question here for your practice comes from 2002, number 18, and the question goes thus: the pressure of 3 moles of ideal gas at a temperature of 27 degrees Celsius having a volume of 10 raised to power minus 3 meter cube is dash. I repeat, the pressure of 3 moles of ideal gas at a temperature of 27 degrees Celsius having a volume of 10 raised to power minus 3 meter cube is dash. So option A is given to be 2.49 times 10 raised to power 6 Newton per meter square. Option B is 7.47 times 10 raised to power 6 Newton per meter square. Option C is 2.49 times 10 raised to power 5 Newton per meter square, while option D is 7.47 times 10 raised to power 5 Newton per meter square. Expected answer here is 7.47 times 10 raised to power 6 Newton per meter square, making option B the correct answer. So expected answer here is option B. Now our next video will be on gas laws dimension with sample question and solution from UTME. I urge you to please subscribe to our YouTube channel, like and share our videos, as we promise to be providing you with more interesting lectures on subjects related to UTME and SSC, especially on the science subjects such as physics, mathematics, chemistry, and so on. Thank you.